Okay, in this problem here, we are given a pair of functions. F is the linear function 4x minus 3. G is the radical function, square root of x minus 2. And we're asked to compute each of the following and also state the domain of the functions. So first up, we're asked to compute f over g. So we do that. Take f over g. Now sometimes you'll have something to simplify. Really isn't much we can do simplifying wise. So there's our function, f over g. And now we come to the question of domain. Well, remember with domain, when we're putting functions together by adding, subtracting, multiplying, or dividing, we first have to look at the domain of the two pieces. So f has no restrictions on its own. G being a radical, stuff inside the radical can't be negative. So in other words, stuff inside has to be greater than or equal to 0. So G has a domain of x greater than or equal to 2. Now for adding, subtracting, and multiplying, you would just look at those two and see, well, what do we have to meet both limitations? But because we're also dividing here, we have an additional limitation, and that is the denominator means x can't be, denominator can't be 0, so x can't be 2 as well, because that would make the bottom 0. And so we then put those together, and we have that x needs to be strictly greater than 2. Okay? Greater than 2 or equal to 2 for the radical, but because it's also in the denominator, it needs to also not be 2. So we have this function here, and we have its domain now, x greater than 2. In our second example, we're asked to compute a composite function. We're actually asked to do the composition G circle F. Remember, when we do the composition, that just means G of F. Right? We're going to do the G of. So substituting the F function into G. So F is the function 3x minus 4, so we replace f of x with that. And then we go into the G function here, and we're going to replace the variable with whatever's on the inside. In this case, 4x minus 3. So that gets me to the function 4x, square root of 4x minus 3 minus 2. And then we simplify. And so now we have G circle F, or G of f of x. It's just the square root of 4x minus 5. And then we return to the question of domain here. When dealing with the domain of a composite function, we have to look at two things. The easiest way to figure out the domain is to remember to look at two things. We look at the domain of the inside function, f, and we look at the what f would have to be to meet any restrictions g has, and we can figure that second part out by looking at the result. You know, what limitations? G only takes stuff greater than or equal to 2. So what values would make sure that f is only giving us answers greater than or equal to 2? Well, that's where we look at the result. And so f, the inside function, doesn't have any limitations on its own. It's a linear function. Then we look at the result. Well, the result is a radical with 4x minus 5 on the inside. So 4x minus 5 has to be greater than or equal to 0. And so our result is that x has to be greater than or equal to 5/4. And then we put those limitations together to get the domain of our composite function, which would just be x has to be greater than or equal to 5/4.